Welcome back to the CTO Playbook, the podcast dedicated to helping CTOs excel. What if the real threat to your company isn't a lack of data, but the fact you can't always explain why the data is changing? In today's episode, we explore that question with Jason McGhee, CTO and co-founder of RIT, whose career spans Pandora, DataRobot, and some of the most innovative work in analytics and machine learning. Jason describes how pairing human intuition with AI leads to cleaner decisions, simpler systems, and a deeper understanding of why your business behaves the way it does. In a world where AI empowers teams to run faster than ever, knowing whether you're running in the right direction or not has never mattered more. I'm your host, Adam Horner, coach to CTOs from startups to enterprises, helping you lead with clarity, confidence, and strategic impact. If you feel like you're figuring it out the hard way, you're not alone. That's why I created the CTO Playbook, a podcast and platform built for tech leaders just like you. Explore coaching, cohorts, and ways to stay ahead at thectoplaybook.com and build the playbook that fits your path at your pace. Let's meet Jason and explore his playbook, starting with the moment he realized that dashboards were telling him nothing about what really mattered. Jason, welcome to the CTO Playbook. I've been looking forward to this one, especially because you've spent a lot of your career helping teams actually understand their data.
Hey, thanks. Great to be here.
Now, for people who don't know you yet, who haven't come across your work, how about we start with a little bit of a snapshot of who you are, what RIT is, and the kinds of teams that you help today.
Sure, yeah. So I'm Jason McGhee, CTO and co-founder of RIT. My background spans from just software engineering to machine learning to UX and design. RIT is a hybrid analytics platform, so we're really trying to make it as easy as possible for people to talk about and share insights on their data, do operational reporting, and even like leverage AI to help you understand and communicate about your business and the data that is describing what's going on and what types of things are going to help you improve your business.
Cool. Now, hybrid is a really overloaded term, isn't it? It's used for a lot of different aspects. So can you explain to us what you mean by hybrid in the context of hybrid analytics?
Sure. So there's this kind of approach that a lot of folks take in all types of business when they're trying to use AI, where they're trying to automate something. So they're leveraging, whether it's classical machine learning or, new age LLMs, they're trying to say, here's this task. I don't want to deal with it. And I want this other thing to do it for me, whatever that means. Now, through my time, especially at DataRobot and now at RIT, I keep coming back to this idea that it's often much higher leverage to help the human augment what they can do using these types of tools rather than trying to replace them. And so you have some analogies that you can make to things like search. So like Google search, you don't always click, I'm feeling lucky. You don't just assume that whatever it's going to do is going to be exactly what you want. You search, you look at the results, and you make a decision of how to go about solving whatever problem you have by using what that search gave you. Similarly with AI, right? You can, especially with how these tools have developed, completely automate tasks by just giving the LLM tools and saying, hey, go do this thing. But the failure modes are often surprising. It will make things up and sound incredibly believable, right? And so by keeping the human in the loop, you can help raise that bar to be much more successful. And so hybrid analytics specifically is about leveraging both, the human and empowering them through the use of a foundational set of tools that we built first before we did any AI, and then helping leverage those for the, user who's using that through agentic and AI type of workflows and augmentations.
So it's this combination of the human intuition, the human knowledge and background, plus the AI's ability to perform sometimes complex tasks in a sort of hands-off automated way.
Yeah, and complex tasks can often be boiled down to a bunch of simple steps. And so especially with the, formalization that companies have made, especially around like software engineering, building these agentic workflows that boil down, hey, here's this large goal. here are all these subtasks. Let's complete them one by one in order to do it, right? And so in the context of BI, you're saying, hey, why did this happen? And it's saying, okay, let me look at the types of connections you have to your data warehouse. Let me look at the types of schemas that exist. Let me look at even comparable reports that you may have been asking similar questions or looking at similar data. And let's take a look at all that and understand what data should we be looking at. And if it doesn't know or it's unsure, it might ask you, hey, is this, right? No matter what, if it's executing SQL to retrieve some data, it'll ask for your approval, similar to comparable workflows. And then it will get that data and say, hey, what's the best way to visualize this in a way that's going to communicate what we want to communicate? And it will suggest a chart, which again, you're in the loop. So you can say, oh, use a different type of chart or color it in this other way, or, add labels or annotations in some way. And then it can put that into a document, can add clarifying information. And then obviously you're in the loop. You can edit any of that. And so doing that in a one-shot kind of thing, if you were blind to what's actually happening, would seem a bit magical, but it's really not. It's just a bunch of small, manually built, tasks that it understands what's available to it and what it's able to do, builds up, set of a to-do list that says, hey, here's what I need to accomplish, and then goes through and methodically completes them. And with the types of state-of-the-art models that are available in things like AWS Bedrock, which keeps everything private so you can be SOC 2 compliant and all that, and no one's sharing your sensitive business data, you can do these types of workflows that are, kind of state-of-the-art in SaaS tooling, like something like RIT.
Got it. So when I looked at sort of all the different things that are out there existing that would enable me to solve these kinds of challenges, these kinds of problems, I sort of looked at existing BPA platforms, so business process automation.
Sure.
And I looked at some of the AI stuff, and I looked at what would the future look like if you blended those things together. Is RIT essentially the future step of BPA for analytics? Is it as easily encapsulated as that, or am I missing something?
Sure. So I would classify business automation and process automation and these sorts of classes of tools as a bit different than kind of what we focus on. So our target user are kind of two groups of people, a reader, like a consumer, and a writer or a analyst. And so this is much closer to the classical, hey, you build a Tableau dashboard, you understand some things about it, and you share it with your director or CEO or whatever it is. But we're really trying to zero in on kind of two specific aspects, which is how do you make the deliverable be the core thing that you're working on? So usually, or often, a dashboard is really not the deliverable because you don't have the context as the person who didn't create it for what the implications of everything that's the signal in the dashboard actually means. So often there's someone who is interpreting it, writing something up, sending it, etc. And so we're specifically working on building something where the medium is the same as the deliverable. So you work in the same kind of space that you deliver, and it's collaborative and all that. So multiple people can work on this single deliverable at the same time, which is very normal in things outside of a Tableau or a Power BI or this kind of thing.
Yeah.
And this is a pretty classic workflow, but we're trying to just, make it much more modern that way and, much closer to the final product. But then also bringing in this, AI angle where we're making it agentic and making it easy to use in that way. And process automation, I would say, tends to be more like, hey, let's, have this view of our organization and how things work, oftentimes through transactional or event style databases, and understanding what's the workflow, what's going on, what are the decisions being made, and take that and turn it into something that is understandable and interpretable, and then making decisions based on, what does that look like, and how can we improve efficiency, and how can we understand, either next best action or potential for churn or funnels and drop-offs or all these sorts of things. So that might be a direction that we end up being able to go based on what we've built, but I wouldn't say that's a focus right now, just because our users and folks who tend to be doing this is they're more focused on kind of cloud data warehouse and looking at, they have applications that they are tracking analytics about, or they're looking at their financials, or they're looking at their sales funnel or whatever it is. And it's stored in something like Snowflake or Databricks, and they are trying to understand it. And we've been edging more into unstructured data just from some approaches that we came up with that allows you to take a look at, say, your Slack data and understand internal insights about your business, often helpful in customer-facing type of roles, and being able to take additional insight and kind of combine that with the more relational, structured data.
Got it. By the sounds of it, then one of the gaps in my assumptions was about how frequently these things were done, because what you're describing, creating almost like a document, an explanation of a particular scenario in order to get insights out of a set of data, which may or may not be on a more widely available dashboard for a particular use case, sounds like it's kind of a custom analysis, a one-shot, one-off kind of approach to understanding a certain situation. Is that closer to the sort of typical use case then? Right.
I would classify it as like two core use cases in that regard, which is one is like a one-off, just like you're talking about. Yeah. CEO or director or someone sees something happening and is like, why is this the way it is, right? Why did sales drop this weekend or whatever it is? They're like, what's going on? Someone go investigate this. That's like the one-off report. But the other is like the weekly or monthly or daily report. There's some cadence that you're trying to understand, some aspect of the business. You're tracking OKRs. You're looking at something, right? And you want to understand that week over week and what's going on. And by making this deliverable be something that whoever the end, reader is like, they just can understand it, right? And whoever's working on it is like, oh, let me frame everything here in the same way that the person who's consuming it, is going to understand it. Then there's like this common intuition, right? And if you have this intuition of what's going on in some area of your business, it's much easier to make informed decisions, because like it's not just a series of like numbers or whatever it is, but it's like, oh, like I kind of understand what's going on. And by surfacing, say like for us, it's the chart that's like in your email, right? You can just go to the report and you can look at the SQL, and someone who has knowledge about what should be included in that can just easily and transparently see that, this like deep dive kind of thing, or play with the data or do whatever, as opposed to the decoupled model of a PDF or a slide deck or whatever it is that has screenshots of these things. And then to be able to like drill down, there's a bunch of friction because you have to like get access or ask someone to do something. And there's like, it's harder. And so people will often just be like, it's probably fine. Or hope that someone who has the seniority or whatever to be like, hey, that looks weird. Like, why is, but this like validation verification thing isn't something that's super low friction. So people just kind of habitually do it, because why wouldn't you? It's like right there. It's a single button click. So yeah, hopefully that's helpful, like paints a picture. Yeah.
Yeah, definitely. I think we get an idea of what it is that RIT does. What I want to do now is sort of pivot from what RIT does now and look backwards a little bit over your career. And just, you've worked at quite a few companies. Perhaps you can tell us about some of them. But the bit that I'm interested in trying to get to, Jason, is what's the sort of the common trend or thread that's tied it all together that gets you to where it is now?
Sure. Yeah. So one of the things that I think is a common pattern in, the career that I've led is I'm interested in a variety of things, and I'm interested in understanding novel or different ways of like looking at the same problem through the lens of varied experience, right? And so when I started kind of my career, I started at Pandora, which was doing consumer electronics, or I was working on a team that was working on Pandora for consumer electronics. So I was always working on different code bases, different products. There were new challenges of like, hey, here's this thing that we haven't seen before, and we have to like figure out how to build things appropriately for it, whether it was like some new codec we had to deal with, or it was some like weird behavior that we needed to do. And so I liked being able to understand, hey, there's lots of different ways to solve the same problem, and, building the same thing in a bunch of different code bases or different languages or whatever was interesting. And it was kind of serendipity that I then kind of fell into startups pretty quickly after that, just through my co-founder, Adam, not to be confused with, certain other Adams. And we built a data catalog. I had, experience in data and doing these sorts of things, but that wasn't what I had, expected to be working on, but it was a cool problem at the time. This was back in early 2017, where Snowflake and Databricks hadn't completely dominated the warehouse database market at the time. And a lot of people had these issues with, they were writing the same SQL, like you and I would be on the same team and we're working through and writing the same SQL from scratch, So imagine being on a software engineering team, there's like no common libraries. You're just like rewriting every utility and library you use from scratch every time. You have this big notepad like on your computer that has like all these different utility functions you copy and paste in every time. Like it's crazy, right? So we were like, oh, that's weird. Like, let's make it not like that. And so we built this data catalog, which is just, a bunch of, you could name a SQL query, and then your coworkers could see that SQL query. And if you started writing something, you'd get suggestions on the right panel that would be like, hey, this looks like this other query. Do you need to write all this? Maybe you can use this and just change a date, that kind of thing. Or you could search, or you could go to your schema and see which queries used that, table. So you could be like, oh, how do I write this thing that I am not familiar with? I'm a new employee and I don't, that kind of stuff. So, we were trying to keep knowledge living beyond the employee who might leave. There might be this one sage, SQL guy who's gonna, leave the company, and so much knowledge dies with, that individual. So we were trying to glue a bunch of things together. And we did a bunch of other stuff, in there as well. But one of our early customers was DataRobot, which was this automated machine learning company. And they were interested in a lot of different things that we had done. And they were definitely interested in our ability to make it really easy to connect to SQL databases. We made that a really good experience, and they really liked that. Yep. And they were in the process of building a data catalog too. So it made a lot of sense. So we joined them, and I probably spent the first 3 months building, or 4 months building the integration and, making our product work with what they had, and integrating code, and helping build the data catalog and all that stuff.
The classic post-acquisition integration then.
Yeah, post-acquisition integration, yeah. But I quickly moved into machine learning, which is something I'd been doing on the side, kind of, going back to this varying interests and trying a bunch of things. And I thought deep learning was interesting. This was probably 2018 I started, or 2017. I kind of started dabbling with deep learning, and I was like, this seems interesting. This seems like it might be something. And so when I worked at DataRobot, I worked a lot with deep learning, and I did deep learning for tabular data, and I spent a bunch of time on that doing research and engineering. But at a certain point, there was this, after I had been doing all this, I was dog fooding the product all the time. So this DataRobot automated machine learning platform, right? I was dog fooding it, working on it, changing stuff, whatever, but I was using the product a lot. And so there was this message that DataRobot had, which was we're going to replace your data scientists. So we can do this thing. You open our product, you upload your data.
So basically a marketing message you mean here.
Totally. And so you'd add your data, and you'd hit the start button, and you'd have either an endpoint or even a full application that you could just use to automatically predict something. There are all kinds of use cases, but one of them, as an easy one, could be you're a bank and you're trying to decide what the risk of loaning someone money is, right? And so getting a metric that tells you how risky it is, something like this. And they don't have to do anything. They don't have to build a bunch of models and do years of R&D. They just upload their massive data set, hit train, and it'll get the best model, that kind of thing. So, but their messaging was, we're going to replace your data scientists. And I was like, I got so much value out of DataRobot, when I was doing all this research and development that I was doing. I think that it can be very high value for data scientists too. And like, I wasn't the only person, who thought this, but I was in a position where I was like, I think we should make this a thing in the product. Instead of trying to just replace all these people, we can empower them. And so this is like there was a product that Data Robot made, or, still has, but I kicked it off and I argued and I played the politics to like get this thing greenlit, which I called composable ML, which was just this thing that when you go into the product and you hit start, it like makes all these pipelines, all these blueprints, which represent like collection of feature engineering and transformations and models to be this final pipeline that does all these predictions and inference. And I said, you should be able to edit these things. And it seems simple, but like just going in there and hitting the edit button, that was like a massive undertaking to be able to make that happen. But what it allowed was data scientists, through both custom code and through this like DAG manipulation experience and being able to swap out tasks and change parameters and do all this stuff, they were able to take their own domain expertise and use the product in a way that it couldn't be used before. And it was suddenly higher value for people who had historically been against the adoption of this software because it was supposed to
limit their jobs,
right? To be able to be something that accelerated how quickly they could actually get something done. And so that, to me, like that stuck with me as this idea. And then specifically for the writ aspect of things, I was just like seeing this all the time. I was in these meetings that were, hey, here are the OKRs this week. Here's the stuff we're doing. There'd be like these large slide decks where people are spending hours like putting together these things, which is a combination of, manual slide deck creation plus, data acquisition and a lot of copying and pasting and duplicating things week over week and all this stuff. And so, a few of those things came together and we were like, hey, this seems like it could be so much better, right? But yeah, so
it's a common thread there. This kind of solving problems that you yourself are facing, but not only facing, but you're predicting what the next evolution of that would be, whether it's putting together data pipelines or putting together reports based on data integrated from various data pipelines.
Yeah, I mean, probably giving me more credit than I deserve, but yeah, it's it fell into place that I ended up working on problems that seemed relevant, and I ran with it, right? I mean, I'm just out of pure interest. It's just like, oh, this is cool, right? And I continue to think that, right? Like LLMs and the evolution of transformers, which I didn't work on specifically. Like I didn't build transformers as part of my work, but I kind of came back or I guess stuck with machine learning. And once it went from something that was a tool I was helping companies use to a tool that I could then use in my day-to-day with, a reasonable understanding of what was going on, how they were working. Once ChatGPT kind of came around-ish, and then a little bit after that, it was like, oh, this is useful. And once it became that they were these kind of little fuzzy functions where you could say, hey, here are some tools, can you like do this thing? And it can do that thing, even if not necessarily super well or whatever. It started becoming pretty apparent to me that, hey, this is going to kind of be the interface. And I like wrote about this back in like 2022, which was a bit before ChatGPT had come out, which was like, I talked about this like declarative UX where, it's been in IDEs for years and I used it like a command palette, right? Which it really wasn't anywhere else or very seldom outside of very technical contexts. This idea of a command palette where you hit a button and all the shortcuts, right? Usually it's just shortcut keys. All the shortcuts are kind of indexed by a description. And so you can type in like, I don't know, format, right? And you don't have to memorize the format hotkey. You can just type in format and it shows the format action and you can hit OK, right? There's also like searching for files and some other stuff. But this is like the command palette. And so now, you have this thing that you don't even have to come up with the dictionary of words and attributions of all these things, though it makes these models much better at understanding. But you can come up with these tools that are the ways of using an application, and you can give them to an LLM, and then you can give this natural language interface, and then a user can be like, hey, I'm trying to do this thing. And as long as you have this like agentic flywheel thing, agentic like loop that's possible, and expose these tools, suddenly you can ask this other thing to operate your application, which is like super interesting. And so you can augment an arbitrary user just by providing the capabilities of your application in a format that this, fuzzy function stitcher stochastic parrot thing, right, can interface with, which is like super interesting, right? And like as they continue to get smarter and this whole AGI thing, it's like, okay, like there's some interesting stuff there, sure. But just this idea of being able to like chain a bunch of dumb things together to like do useful stuff is like a pretty impressive capability that I think has like really been continued to be like pretty untapped outside of like, very forward thinking organizations plus like Silicon Valley and, a few other places. And so, I don't know.
Back to the kind of the Unix concept, doesn't it? Of, simple tools that are easily chained together to form arbitrary workflows. It's sort of the same concept, just sort of expanded out to almost, planetary scale or something, rather than just operating in your Unix operating system. But I mean, in terms of the actual interface, I presume here we're talking about the MCP interface and how easy it makes it to expose a tool to an interrogatable interface, right?
Sure. I mean, the MCP is a protocol that became standardized after the like function calling tool use APIs had kind of already existed. So OpenAI, Gemini, or I don't even know if it was specifically Gemini, OpenAI, Google, and Anthropic all supported these various ways of doing what was called function calling originally, and then I think became tool use before MCP standardized things a bit. But you would give a JSON schema and you would have these, effectively you just parse the functions that the LLM said, hey, okay, here's the input parameters, like here are the input that I want to give, which is just filling the schema you specified. And I want to call that function, right? And that function would be actual code in your client side thing that would execute something and then pass the result back to the LLM, which could then take another action or do whatever. So MCP was just something that was a interface into like a standardized way to be able to call things in general, but like it certainly wasn't necessary for the kind of workflow that I'm talking about. What it does is it makes it very easy to call to like external tools that you didn't define yourself. So being able to take external actions and these sorts of things.
Got it. So it expands the effective boundary of what you're capable of doing massively.
Yeah. I mean, similar to like the way that like REST works, right? I mean, it's once you have that or similar things, it's like once you have a standardized way of doing things, then you can build abstraction that makes it very easy to interface with things that talk, through that same kind of interface. So I think it's great. It's cool that we came to a standard. I don't think that it's like this massive game changer thing. I think that it just lowers the barrier to entry a bit for doing a lot of these things and removes the like necessary glue and this sort of stuff. Yeah,
which can often lead to just massive adoption, which is hopefully what we're going to see. Because I know there's a bunch of companies that are sort of betting significant futures, not least the AI hyperscalers themselves betting literally billions of dollars on it. So let's see how it goes. But what I wanted to do, Jason, actually, is to sort of drill down a bit into what you've got to and how you've got there to. How you went about building it? What are the sort of the principles that you've used in your leadership? Because I believe that RIT is still a relatively small organization at this stage.
Yeah.
But how have you essentially brought together all those people, those ways of working and so on? And what are the sort of the key themes that you run with to make these things possible?
Sure. Yeah. So one of the things that I think kills a lot of velocity for, being able to build a product is just, a couple of things. One is like trying to do too much. One is like betting on something before you know that it's actually the right thing to bet on. And then, I think that's probably most of it is like right there is like, with velocity. So like you can solve a lot of that just by being more aggressive about cutting scope. So you're just like, hey, what's actually the thing that we need to build here to like prove this idea is good before we go in and like invest a huge amount of time in this, which like that doesn't necessarily mean don't ship anything, or that doesn't necessarily mean that you like do immediately put something out in front of customers that's like not built. It's like come up with a way that you actually prove value and like build the thing that you need to prove value, rather than, some people will go and spend a year building something and then it's not right. And like they had what would have told them that within the first month or something like this. And so or just, if you're like sprinting always and you're, sprinting towards building something that's not right, like you get tired and, you want to spend your energy wisely. And there are certain times where sprinting is like the right thing to do because there's like some reason, right? It's like, oh, this customer wants this thing and it's a big opportunity for us. And so like, let's work hard now. And if you spend that energy on things that don't pay off, which will happen no matter what, then, you have less energy to work on like when it matters most to kind of spend that. So allocation of resources is kind of the dry way to talk about that. But yeah.
And your test, therefore, just going on the implication from what you said
Sure.
there, your test, therefore, of whether something's working or not is basically based on opportunity and revenue. Is it as simple as that, or is it slightly more complex than that?
Yeah, I think that's a quantitative measure of it. I think there's a qualitative measure of it too, which is just like people like it that are your target customers, right? They're like, or get value from it, right? And they're, a good like signal is they're willing to pay you money for it. But there is something to, be said for, hey, try this thing out. Is this, useful to you? What would, make this more useful to you? Or, something like this. And so I feel like there are absolutely cases where it takes a large amount of time to create something that is actually going to deliver the key value. And like, until you build that kind of whole picture, it is not very useful or not very compelling. But I think a lot of times people over design, certain features, which are like, hey, we need this, 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 and this. And, I think Pareto principle is like absolutely a smart thing to do at all times, which is like, is there some subset of these things that's going to take a fraction of the time, but deliver a majority of the value, right? And that is like, if you can always do that or do that consistently, like what you can ship in terms of like product value for the amount of effort and time that it takes, it will be like, it's a much better trade-off rather than like always trying to build the 100% thing.
So you're very much a fan of the Eric Ries approach of validated learning, where you're basically picking up information coming back from the customer and what it is they're going to do based on building, let's say, you mentioned the Pareto principle there, so 80% of the capability with 20% of the effort, for example.
Sure. Yeah. I buy it.
Got it. And I think in terms of, spending a long time running in the wrong direction, as you put it, that is one of those things that it costs in multiple different ways, doesn't it? Because there's not only the lost time of running in the wrong direction, there's also the time lost of getting back to square one, if it's even as simple as just retracing your steps, because sometimes it isn't.
Yeah, I mean, it also just sucks. Like, it's like, man, like I just worked so hard and like it wasn't it. Right. And that's rough, right? It's, if you, as a bad analogy, the optimal way to get to a, timed public transportation is to always run as fast as you can to get there. Right. But if you do that and you just miss it, that feels a heck of a lot worse than if you had just walked there and, arrived halfway in between, the two trains or whatever it is, right? When you just miss it, right, it feels pretty bad, right? And so, if you expend a lot of effort and end up failing versus, being conscious that it might not be the right time to spend all that effort, right? Because ahead of time, or you plan, or whatever it is, you gather information to be able to determine, no matter how hard I run here, it's not going to be successful. So, let's invest our energy in things that will actually be potentially pay off, which, it's easier to say than to do, but
no, absolutely. But I like that distinction. It's not just about running in the right direction. It's about how hard you run in any given direction. If you're running gently, you've got more time comparatively to figure out which is the right direction and change course earlier than if you've been sprinting hard and effectively sometimes not able to look at the other data or the other information about which direction you really should be going in.
Yeah. So something along those lines, you probably put it more eloquently than me, but yeah. And I think there's something to be said here as well, which is around whatever term, you're using around like dog fooding your own product or doing the testing or, trying to like make sure it's actually doing, it feels the way you want it to feel and works the way you want it to work. I think it's often easy to be tunnel visioned into some specific aspect, some specific thing that you're working on, like one feature or one aspect of one feature, and like taking a step back and like, understanding how it feels all together, even if you're looking at it from a technical perspective, right? Maybe you might say, oh, that's not my job or whatever, depending on your role in an organization. And maybe that's like a designer's job or whoever's job. But like often what happens is people are focused on the project, the feature, the thing, and less looking at like, how does it all feel together? And like, what's the cognitive load on all these features together? And I mean, some organizations are like very disciplined about this, and they're like, they track analytics on every single feature. And if a feature is like not what they like, come up with a threshold of like what success is. And if it's not meeting that threshold, they just rip it out. And by doing that, like if you do that, right, you reduce the like engineering maintenance effort, right? Because there's just less to have to like, develop and think about and consider. And when you're adding a new feature, like how does it integrate with that? And, are there like patterns that you have to follow now or any of those things?
I've seen that so many times in large organizations where people assume that all those edge cases are just 1 + 1 + 1 + 1, forgetting that there are sort of multiplicative effects to them as well.
Absolutely.
Whereby each one you add, you've got to also combine all the other sort of edge cases you could affect with that one that you've just added.
Yeah. And like, even if it's like not like directly affecting, it's just, there's just more, right? And so it's like more to understand and more to know and more to, whatever it is. And even for the customer, like even just the user of the product, it's like, it's much harder to use a product that has like 50 capabilities than it had like, if it has like 5 capabilities, right? Someone opens Photoshop for the first time, they're like, what on earth is, like, I have no idea what any of this means. Just a bunch of glyphs, right?
And each button seems to open 10 more.
Yeah. Versus like Google Docs, which is, you like, there are more features there, and maybe it's just more about hierarchy or whatever, but it's like mostly does one thing, right? It mostly is like you type stuff in, right? Maybe that's like an unfair comparison, but like you often see startups like that have a successful product where all they really did was removed a bunch of features from something else. And it's like truly, like, it's like, oh, like we used modern design, whatever's popular right now in terms of modern design, and then built some tiny portion of the like highest payoff parts or highest value parts of some product. And now it's like more, gets adoption and success and whatever it is, because it's just easier to use, because there's just like, and so you don't have to worry about all the stuff they have to worry about too, which is like, so you can like ship faster too, because you don't have to worry about, oh, there's like this one customer that's still on like 50 versions ago or whatever it is, or still uses this like legacy feature, right? And so there's like this fresh lens that you can kind of work through. And so that, I mean, you can become the legacy code base yourself very quickly if you are adding unnecessary things. And so I'm a little concerned now that, people keep talking about like how low the bar is for software engineering now with all these agents and all this stuff that they can do. But they have a huge tendency to add, like no matter what, to solve a problem, you like add more to solve it.
We're very rapidly heading back towards that sort of 1960s view of a nuclear control panel interface to something with a billion buttons and dials and gauges all over the place.
Whether or not it ends up showing itself in the UI like that, the code base itself will become not only like have a lot to understand, a lot of complexity, a lot of maintenance burden, all this kind of stuff. But there's something very different about actually thinking through and understanding something and coming up with it yourself and building it. Like the intimacy of your knowledge with it is very different than if you have a coworker build it for you or an employee build it for you, and your like understanding of it, even if you read all the code, is different. And when a human writes something, the types of failure modes tend to be pretty familiar because like you've probably made all those mistakes yourself. So they like are recognizable and you like, it's like easy to like spot those kinds of things. But when like agents like build things differently, it's like fundamentally different. The types of mistakes they make are just like fundamentally different. And so it's much harder to catch because it like looks like the code doesn't smell bad in the same way that like human code that probably is buggy smells bad because there's like signs. So it's like, oh, it looks like they didn't really know what they were doing here. Right. Where it's like the agent, it's like, it looks like they knew what they were doing and yet they still made this,
They failed in a completely different way. Yeah.
And so those two things together of like not having the same interpretability and understanding and not writing it yourself, like less and less of the code base, you will have the kind of understanding that people have, like 2020 and before. And so like the like volume plus the difficult, like the complexity. I'm thinking that like many code bases will be legacy, like kind of immediately. I mean, and like a lot, like people who have been in the industry or like understand what it feels like to use a legacy code base. It doesn't feel good, right? It's hard. It's like much harder, right, than a greenfield project. And so Absolutely. If every project is a legacy project, like that's going to be rough. And so
it might be, but I view this from another perspective actually, because what I think is happening is that the cost of software is dropping so rapidly. That, as you said, we now can afford to have software created pretty much on tap. The same way you would go to the sink and you open up the tap and you expect water to be flowing out of it. Sure. I think we pretty much have the same view of software now. With software is just custom software is coming out everywhere. And therefore things can have much tighter use cases, much smaller use cases, and much smaller lifetimes as well. And so what I think we're probably going to move towards is an era, a world in which we use custom software everywhere, all the time, for everything. But everything is streamlined to just do this one thing once or just a few times. And so therefore software engineers, in the traditional sense of a software engineer maintaining a corpus of software that lives over a period of time, will become either a lot more specialized or a lot more abstracted. In other words, that it deals with a problem and creates an abstract interface that some other, much more temporary, much more throwaway software can use as a component of what it does. And I think the definition of software is going to change considerably over the next few years as that becomes like the same way in which, when TV first became available, we take a stage show and we put it on the TV. And, the stage show happens, once every quarter because to put on a new one costs a lot. Whereas now we've got so much TV, you can't possibly watch it all, even if you tried. You'd have to have something like 16 pairs of eyes to watch all the TV there is available. I think the same thing will probably happen with software. And I think it'll have a big change on what we view as quality, because testing, how do we make sure the software is correct? I think it'll change the amount of complexity. Each piece of software should become a lot simpler and tighter, much like you were suggesting, being able to cut scope, right? We don't need nearly so much scope if we can create, software uniquely each time. And then, as you said, if we're doing the right thing, it becomes a lot clearer. We're just building it for this one thing wants, rather than trying to anticipate some complex, perhaps unfathomable use case that we've got to measure and figure out first.
It's an interesting, I think you'd really need to build some specialized tooling to be able to use that in a lot of contexts. Like you're talking about this kind of ephemeral, just-in-time code, like very temporary code is like this idea. And if that's the case, if it's kind of this, that kind of framing, things like reliability, security, compliance, all these types of things, suddenly that's much harder. I mean, it's very different.
Yeah, I agree. And I think software gets stretched out over a spectrum. Much like in the days when we had assembler, all code was written in assembler because that was the only way to write it. So, it had to be run and tested multiple times. And then once it was working, you didn't touch it for, decades sometimes. Mm-hmm. And then software became easier to maintain when it was moved into C, and then even easier again as we moved into things like TypeScript and so on. So I think there's a sort of a continuum that we might see, stretching out over time, I guess. But I don't think that changes some of the other things that we need to continue to do. So, for example, I run some code, I figure out what's wrong with it or what's right with it, I fix it, change it, redeploy it. And I think that this idea of what's broken about it and how do I fix it? Because that's another thing that people often talk about, isn't it? Is how do we get quicker at fixing code? I think that becomes even more important, right? So we almost like test it, fix it within seconds, rather than a feedback loop that can be longer than that. So yeah. I think, and again, it's look at a trend and take it to an absurdity, because the reality will probably be somewhere between there and where we actually are. But I think it still highlights some of the core principles of the way in which good software is built these days, just in a different sort of future world.
So do you think that it will be much more like humans and engineers will spend a lot more time focusing on like tests and validation rather than the underlying
I think there'll be a lot more of at the moment it's sort of a human or a team and some tooling. I think what will happen is that tooling in agents and AI and so on, it'll become a lot more prevalent and probably outnumber the actual number of software engineers. So the amount of code bases that a single engineer can sensibly maintain with different contexts will continue to increase. So will that increase the amount of demand on all sorts of things like testing and frameworks? Yes, absolutely. I think that's going to have to change by an order of magnitude or two. But I see that when we look at some of the AI first companies and the way that they're working and how they're coding, that's kind of the direction that things are going. I mean, you're obviously looking in the world of data. There are teams doing for coding what you're doing for data. And so I think the trends of where this is going, they're converging on a view that is somewhere in that region. I don't have a crystal ball like the next person doesn't either, but when I look at what's happening and the changes I see across coaching, it's very interesting to see that there's a few core concepts which are coming again and again. And you mentioned that cut scope early and often, and it doesn't matter how fast you run if you're going in the wrong direction. And I think that's absolutely true. How do you know you're going in the right direction? Well, you've got to test it, measure it, work it out somehow. And I think that this idea that complexity is the killer. Then, well, we can go back to that original unit concept, keep things really simple and straightforward, chain things together in a way. And it's that chaining together that become the bash, the scripted version of the software world. It becomes a lot easier to chain together well-tested, reliable software in a way that creates a whole that's much more than the sum of the parts.
Yeah, I would say one thing that's I definitely agree with is it's a lot cheaper to explore now. Right. And so there's this like phase of software when you're trying to understand what the right thing to do is. It's much cheaper to do that now. It's much cheaper to try things out. Right. And so especially if you like build the proper guardrails and do these sorts of things, you can try a lot of experiments doing, vastly different things and like see what feels good and see what works, especially with like, front end has gotten a lot, which is, I feel like that tends to be where a large part of experimentation and is like tends to be with like UX, right? Like tends to be where
how do people experience our software?
Yeah, like you have to try a lot of things before you kind of find the right thing. And so as the UX front end aspect of these things has gotten better, and it's also like less of a problem when it screws up, right? Like for a lot of different cases where doing something like the kind of failure modes you tend to make on the front end, other than, obvious ones like leaking keys or, those sorts of things, tend to be like less of a blast radius kind of thing, right? Like if you have errors or bugs or whatever in your front end, you're impacting the users that are like directly involved in that situation, versus, if you have those sorts of failures in, important critical infrastructure, you affect everybody, right? Which is, we've seen that, right?
And lose your database, everybody knows about it.
Lose your or just like, a server goes down because, it like your vibe code had a null pointer exception, and it like the server had to restart or whatever, or, whatever it is, the process had to restart. And like, who knows, right? I mean, nowadays, if you build infrastructure properly, like, hopefully users get load balanced off and, move somewhere else. And it's like, you don't notice it or whatever. But you can definitely come up with issues where, you have downtime for whatever reason. And an endpoint stops working, or who knows. And so I think, I like experimentation, I think, is like definitely prototypes, and that's going to be interesting to see. I think you're a bit more optimistic than I am on some of the kind of use cases that you're talking about. Like we'll see. Like I certainly agree with the augmentation aspect of things, but as like the closer that we get to the kind of automation stories and like what we can automate, I haven't seen that be as successful. But that being said, you're not going to see, I don't think you'll see people posting on Twitter about the very successful things, because they'll be monetizing it or leveraging it to great effect, where they have whatever it is that they've found or done. It's like, why would you go show other, cynically, why would you go show other people that? Because like that can be the core of your business. So, but we'll see, we'll see how quickly that ends up going. And there's this whole other conversation around like, what does this mean for people who are just entering the industry, and like what should they be focused on learning, and like what should they be doing? Because like today, at least right now, at least in my experience, if you're working in a domain where you don't understand the domain, or you're working in a whatever it is, and you like don't understand the kind of gotchas and thorns and things, you tend to have a much worse time. So the types of guardrails that you impose on these kind of agents tend to be a pretty clear indication of like how successful you're going to be with that. So the kind of people who could write the program, their vibe coding or whatever it is, whatever the right term for that is, already, if they were to do it manually, it's going to be way easier for them to do it using an LLM than someone who has no clue how to write that thing properly, and they're trusting the model, and they don't see the like clear problems immediately, right? So
as another coach put it when I spoke to him, he said, whether you know where you're going or whether you don't, AI is going to get you there faster. Interesting.
Yeah. I suppose that's true. Yeah, because it's a good one. Yeah.
And talking about that, getting feedback from customers and getting information on what people are actually using. I think that's another key area of yours in terms of getting feedback, right? Is to understand what people are doing. What is it you do with your teams to try and shorten that feedback cycle?
Yeah. So I think there's like feedback loops in general. There's like development time feedback loops. So just when you're building, right, is a huge one, which is, like you talked about, the further you go back in, engineering history, like the time you had to wait before you see what it is that you're working on, working, was like a long time, and how quickly you can change things and see what impact they have, right? It's like a long time. So I think you can kind of do that throughout the kind of stack all the way to the customer, which is like, you can experiment often. You can just try things. You can ship, features and like ask someone to use it. You can use feature flags, so you can have like one customer use it or whatever it is. During development time, you can set up your environment depending on the type of language that you're doing. But most tools and languages and these sorts of things, you can set up, hot reload, and you can set up all these kinds of like very fast feedback loops. You can say, okay, let's, build this thing. I mean, even the like single most popular library for building front end is React. And it has this built in because it's like so valuable, which is you can have your app open and you can be editing the code in your IDE and it's just like updating automatically in your browser. And so that's a very fast feedback loop. And so if you can structure the types of things that you do in a similar way, where you can understand the implications of what you're doing and you can understand, very quickly, by using whatever you're using and going back to the code and, whatever, or similarly, customer uses what you're using. If you have proper observability, understanding if something goes wrong or something goes right, what is it, what are the implications? What does that mean? And so that, I think that's important, like super important. And so if you can have this kind of fast feedback loop, you can, build so much faster, whether it's a company or a product or a, specific feature. Yeah, that's kind of my thinking there.
Extending from that fast feedback loop, one thing I've found as well is once you've discovered something that doesn't work or that breaks, is to ensure that you try to not let that breakage happen again.
Sure.
So for example, one of the things that I introduce with almost all the teams I work with very often is a rule of no regressions. So the very first thing I get to do when a bug is reported, the very first thing I get somebody to do is, okay, now write a test that proves that's a bug.
Right.
And once that test is written that proves it's a bug, then the build is never going to pass until that test is fixed. And therefore the bug is fixed and should remain fixed because that test case will stay in the test suite. And so therefore zero regressions by design. But you kind of took that a little bit further than what I would say. And so you basically say, okay, make sure that the tests operate as the customer operates it.
Oh, okay. So this is end-to-end tests or automation tests. Sure. I mean, it's part of the like test pyramid in my mind. So to address what you talked about kind of first. So one thing, there are a lot of ways to write tests and there are a lot of bad ways to write tests. There are, maybe people are familiar with the term of like glass tests, which is like you have some code and you don't want your coworker or someone else or some unknown individual to break the code. So you write these tests that do things. I've like seen these tests. Like you write these tests that are like, call this function, like make sure this function is called, like put a spy on this function, make sure it's called like 3 times. And it's like, okay, but like if anyone refactors that code and it's still actually behaving completely properly, your test is going to now fail. And now you just added a bunch of maintenance burden and they have to go fix that. So similarly with this like bug case that you had where there's like, hey, like first thing to do, go write a test that you confirm it appropriately fails, for the case that you suggested. As easy as that sounds to do, like from the way you framed it, there are a lot of ways that someone could write that test that is not at all what you meant, right? Where like the place that they chose, the layer of abstraction they chose to write that test was like inappropriate. And so like you want to choose the right layer of abstraction, which like demonstrates that issue such that if at all possible, there's a lot of freedom to change aspects that the test shouldn't be concerned with. Like,
right.
And so for us, like the format that takes in the example you gave was like, we use like Playwright, which is a browser automation type of library, a successor to Selenium. And so because our product is like, operated through the browser, if let's say for, the sake of argument, you encounter a bunch of bugs as a user. And if those bugs are all in the, like, let's say there's, 5 bugs you encounter over the course of a session. If all those bugs are in the like front end and you see things break and, there's like something went wrongs or error messages or things freeze or don't work, but whatever it is, versus a bunch of 500s that there's like retry logic or fallback logic in the client or whatever it is that can adapt to whatever that issue was and like do something else, some weird, whatever it is, some fallback logic. if the user doesn't notice anything went wrong, that's a lot better. Even though there were like all these issues, or if it was like a little slow instead of it didn't do what they tried to do, right? It didn't do what they expected it to do. That's a much better way to fail. And so by having tests that are testing, like in addition to, other good testing practices that are actually operating the app in the same way that the users operate, and you have these familiar paths, users take these paths, we need to make sure these work appropriately. Here's what the user should be seeing here and here and here, or here are the actions the user should be able to take at all these different points. If you have those tests run on every PR or whatever it is, then you're at least affirming that the kinds of workflows that the customers are actually going through and seeing work appropriately. And so, like, if you don't have those and you don't have end-to-end tests, right, that are actually testing all these things together, and you're just doing unit tests or just doing integration tests, you're like ensuring they work independently, but they might fail when actually being used from the perspective of the user, which is like not great, right? And so if you're testing it for the front end case, if you're testing each React component in isolation and making sure it all behaves accordingly using like, jest unit tests or whatever it is, you can, or like component testing, that's great. But like in practice, if the API sends some stuff that the, whatever wasn't expecting, or who knows, and, it's like, it's not great, right? So by enforcing, those and building, and it's like pretty easy. You can even like click record in Playwright and then like, go through the workflow, and then it's like, okay, you have a test. The like CSS
I think
selectors.
That's where the original name came from, wasn't it?
Say that again? What do you mean by that?
Click record and then replay, so Playwright. I think that's where the name of Playwright actually came from.
Oh, interesting. I think it's spelled like, unless I'm just wrong, which I could be. I think it's spelled like a playwright, like someone, a puppet master kind of thing. Because I think it was built on top of Puppet or something similar to that. Puppeteer, yeah. So I don't know. I'm a little skeptical, but maybe you're right. I think it was built on top of Puppeteer, and so it's like a higher layer of abstraction. I don't know. I don't know the etymology of the name, so we could go look into that. But
either way, you're advocating for using tests that use the app in the way they use it. So testing the user experience rather than just testing the components and pieces of it, which is all good tests as well. But you need to have that full user level interaction test as your perspective there.
Yeah, and also as a individual, you should be testing that things work from the perspective of your, customer as well. Like, manual QA is good too. And so however it is that your customer is using it, writing tests and using the product, how they use it with similar, whatever it is for your product is very different product to product. But one thing I see happen in random software I try a lot is in all the demo videos, they have been using it for a long time. Whatever that means something very different across a lot of products, but they've been using it for a long time. And the first time user experience is like really different. And things like don't feel good and don't look good. And you like don't know what to do. You're like, all the stuff I saw in that video like isn't here. I like don't know what I can do. And so that's an example just of like using your product like customers do, which is like a new customer, that's their first experience of your software. And so arguably it's more important for people who've never used the product to have a good experience than people who, have been using it a lot. And like, you think a lot about like, how well do things scale if they get to like 100 or 1,000 items, which also is an area that I see fail in other software, which is like, oh, what if someone actually starts seriously using your product and then it falls over? That's a good problem to have for what it's worth. Like it's, you don't want to over future proof or whatever too much, because who cares if your product can handle 1 million items if users only upload 5 or whatever it is. And so, using your product like customers do, whether it's through tests or manually.
That was really highlighted to me beautifully recently, where I got the privilege to watch a product demo by some developers to the leadership of this organization I've been invited to. And it went through pretty much exactly the story you're talking about. The developers went through and demoed the little pieces they were working on in Indeed. They were fast and efficient and very good. And then the CEO himself said, okay, just step back a bit, folks. I want to create my own account. Just show me how I create my own account. And he just highlighted right there and then, very visibly to everybody else, that the onboarding experience from scratch actually was a bit tortuous, and that everybody kind of skipped over that bit because they'd had their accounts signed up and logged in on their dev environments for so long that they'd kind of forgotten that there was this 17-step process to go through onboarding.
Yeah, there are services which are, you can pay some amount of money for like paying, like if you don't have like friends or customers or whatever it is, like you're very early and you don't have a, portfolio network or whatever it is, right? And you can pay these services where like a random person, and you can like specify what kind of experience or whatever they should have, will use your product and like go through these workflows, right? And you get a video, and so you can like see them using it, right? And so we did that like early on a bit, like just to like, for onboarding and things like that, where, it's so funny when the first time you do it and it's like, oh, there are all these assumptions we made and we need to like fix them. And so fortunately you can do them like one by one. So you can like really screw up on the first one and like fix all that stuff and then come back and like do the rest. But it's amazing because, I've seen like videos, fortunately this didn't happen to us, but I've seen videos where it's like, okay, now, sign up. And they're just like, no clue. They have like no clue how to sign up, right? And they like can't figure, they're like actively like, I'm trying to sign up for this product and I cannot figure out how to do it. And the people who are watching are like, it's right there, but they can't, like, you can't interrupt, you can't say anything. It's like blind, which is great because it really helps like drive that home of like your familiarity with the product, right? Is so different that things that just seem obvious to you are, just like super, not obvious to a random first-time user.
And it's a big learning point, isn't it? Jason, this has been a lot of fun. What I'd love to do now is try and sort of condense all of this down into a playbook that represents what you've been going through. So I think let's just go through a first few steps on this. And number one, make sure you're going in the right direction. I think your phrase there was, it doesn't matter how fast you run if you're running the wrong way. Number two, very sensible, cut scope early and often. I think this is very indicative of the iron triangle. So your view is to cut scope rather than cutting anything else, which is a very common approach, but essential from the point of view of reducing complexity in your playbook. Mm-hmm. Number three is very much about that point, is the complexity. So reduce complexity, remove or simplify whenever you can do. Point four, which was spent a lot of time talking about, was in making sure that you're testing in the way that your users, your customers actually use and operate your product. Mm-hmm. Number five, shorten the feedback loop. And you gave some great examples of different ways in which you can do that on several different levels. And then the point that we started with, point six, which was augment people. Don't automate them, don't replace them. Mm-hmm.
Yeah, I feel like that sums it up pretty well. I mean, there's like a ton, there's always more you could add to that. And there's, nuance and, whenever you're working in an environment, like what's going to matter more changes. But I think it's just important that, you can, try to choose to do the right things and learn as quickly as you can, right? I mean, is a very shortened and condensed version of all of that, I feel like, and yeah, I mean, there's a lot that's fun that isn't necessarily going to put you on your kind of critical trajectory to where you're trying to go. And it's easy to like get lost in the weeds. And, but yeah, I mean, it's I think a reasonable, set of, goals to have for yourself when you're trying to build a company.
And I'm sure there's many of our listeners that will agree with you. Jason, if they want to continue that conversation with you, how can they get in touch with you?
I'm on LinkedIn. Happy to connect. If they want to do that, it's probably the easiest. We can figure anything out from there once we do that. But yeah,
excellent. We'll put that link in the show notes. And if anyone wants to try out RIT, the URL for that one is.
Sorry, I thought you were going to say it. It's rit.so, so writ.so. And you can email me if you want to at jason@rit.so. I suppose that's an easy way to reach out as well.
Excellent. Jason, thanks so much. It's been a fascinating conversation. Thanks so much.
Thanks. Appreciate it.
Thank you for listening to the whole episode. I appreciate your time. So just before you go, I'd like to ask you for a favor in return for putting together this episode of the CTO Playbook for you. Please share the episode with just one person who will appreciate it. Wherever you're listening, whether that is Apple Podcasts, Spotify, Amazon Music, or another platform, sharing the episode will help more CTOs find the podcast and enable me to create more great content. Remember that you can find more information on the CTOplaybook.com. Thank you for listening, and I'll see you on the next episode of the CTO Playbook.